Okay. Are you able to see the screen? Because I am not able to see the screen.
नाही मॅम, स्क्रीन नाही दिसत आहे.
Yes, yes, I'm sharing it again. Okay. I think now we are able to see the screen. Correct?
येस मॅम.
Let me come back to the screen at my end. Okay, so we are at the chi-square test. Quickly, the revision of chi-square test. What was this chi-square test? Come back to the screen. And so the chi-square test has two types, the goodness of the fit test and the chi-square test of the independence. Now, the most important part is this is the statistical test for the categorical data. What is the categorical data? So the categorical data is the data where the type of the data where you have the categories. What does it mean is a gender, male, female, or you have the something like the hair color, that is black or brown, eye color, or the rainfall. So rainfall also can be the heavy rainfall or the mild rainfall, the temperature high or low. So these are my categorical data. And for this categorical data, when I conduct some test, a statistical test, that's called as the chi-square test. So there are two types of this chi-square test: the goodness of fit test and the test of the independence. Correct? The formula for the chi-square test, we all have seen. The formula for the chi-square test is O minus E, the whole square divided by E. So again, I will repeat the summation of the observed minus expected frequency, the whole square divided by expected frequency. That's the formula for the chi-square test. I hope this is clear with all of you, the formula for the chi-square test. And moving ahead, we'll see the numerical directly. I hope this numerical you all remember, correct? So over here in the numerical, what I said is the die is thrown 60 times and the observed frequencies are, so the number of times the phase 1 has come is 8. The number of times the phase 2 has come is 10. The number of times the phase 3 has come is 9. The number of times the phase 4 has come is 12. Consequently, the 5 has come 11 times and the 6 has come the 10 times. And what is my claim is to test whether the die is fair. That's my claim. So moving ahead, I will be drafting the hypothesis. That's the step one in all the statistical tests. We need to draft the hypothesis statement. So the hypothesis statement is H0, that's my die is fair, and H1 is die is not fair. Expected, the step two will be calculation of my expected frequency. Now, since I say that the die is fair, so what is my expected expectation from the die? There should be the equal probability. So I will be having the frequency of every phase to be equal. That's my 60 by 6, which is my 10. Okay? So this is one of the simplest example to understand what is the observed frequency, what is the expected frequency. So my observed frequency is through the experimentation. I do all the experimentation. What does it mean? 60 times I roll the die. 60 times I roll the die. And I note down whatever has come the output when I roll the die for the 60 times. Correct? But according to me, right, through the theory, through the standards, what I expect that the die is a fair die. So it means that the every phase should come equal number of the times, right? So when I roll the die for the 60 times, I am expecting that every phase should come for the 10 times, right? Because there are 6 phases, so I am expecting that every phase should come for the 10 times, correct? I hope you have understood the difference between the observed frequency and expected frequency. The observed frequency is the one which I observe when I do the experimentation. So I actually roll the die 60 times and I note down the output of the every roll. That's my observed frequency, which is given in the numerical. This is clear. And what is my expected frequency? As I say, the die is a fair die. So it means that I am expecting that every phase should come for the equal probability. Correct. So every phase should come for the 10 times. That's my expected frequency. Now I will be putting these values in the formula. So the formula for the chi-square test is summation of observed minus expected, the whole square divided by expected. Very simple formula. This we have already done in the class also. So here I have a table where I have the observed frequency. I have noted the expected frequency and the calculation of this formula. So my observed frequencies were this, which was given in the numerical. My expected frequencies, as I already said, I am expecting that every phase should come the equal number of times, because I claim that that's my the fair die. Correct. So the answer for the expected frequency is 10, 10, 10, 10 for every phase. So after doing all this, the formula comes down to the answer comes down to the chi-square test is equal to 1.0. Now the next step is my decision step. The next step is my decision step. Please remember this. The next step is going to be my decision step, where the first task which I need to do is the calculate the degree of freedom. Are you getting this? The first task I'm supposed to do is calculate the degree of freedom. So degree of freedom is number of variables minus 1. That is going to be my 5, because I have 6 spaces, right? So 6 minus 1 is my 5. Now the critical value calculation. So what I'm supposed to do, I told you also in the class, I am supposed to calculate the critical value. The critical value calculation is done through the table. The critical value calculation is done through the chi-square test table, and the chi-square test table, we are supposed to note down at which degree of freedom and the at what significance level, what is the standard value. Correct. So looking back, I will be showing you the chi-square test table. Just a second. Chi-square test table. So just give me a second. So we will share this chi-square test table. So please open the chi-square test table at your end and check with what is the value of degree of freedom when I have 5 and the critical value as 0.05. What does the value comes? Can anybody answer me? What does the value comes for this? Okay, I will show it over here also. So just any table you can look into, and then see. Just a second. Okay. Um, okay, for a second, I will be sharing everything. So I hope you are able to see the screen. So over in on the screen also, you can see that at the degree of freedom of 5. Are you able to see your freedom of 5? Yes. Oh my God. At the degree of freedom of 5, you can see that we have got the standard value as 11.07. I hope the screen is visible to all of you. So I will just stop sharing the screen. Back to our numerical. So at the degree of freedom of 5, we can see that the value is and the significance level of 0.05, the value is coming as 11.07. And what is the value which I have received in my chi-square test? I have received 1.0. So this value, this particular value is much lesser. Correct? This particular value is much lesser than the expected value. Yes, am I right over here? So what I'm supposed to do in this case? This value, see, my test statistical value is lesser than the value. which is there, correct? So I will be accepting my H0, right? And I would say that die is fair, correct? See, this is what we can see that I hope you remember what we have seen in the table of alpha. There is a graph, right? There is a normal bell curve, and at this end you can see the alpha over there. So what does that alpha says? That alpha says that, see here, hypothesis testing. I hope you are able to see this graph. I will show you the graph over here. Yes. Yeah. Yeah, the graph over here, right? You are able to see this graph, correct? So in the graph, yeah, in this graph, you can see that there is alpha, correct? So my value is after this, I am calculating at this alpha level, at this alpha level of 0.05, correct? I am calculating the value at this alpha level. This alpha level is my 0.05. What is, and at degree of freedom of 5, what is the standard chi-square test value? So the standard chi-square test value at this level was 11 point something, correct? So it is over here, some value I am calculating as over here, correct? But what is the value which I have received to my t-test? The value which I have received through my t-test was, I hope you remember, the value which I have received at t-test is 1.0, correct? So that particular value, that 1.0 value is going to come is at this side, at somewhere over here, correct? Because this is my middle, this is going to be 0. So whatever I get after 11 is after this. Whatever I get less than 11 is going to be on this side. And this is my region of accepting the null hypothesis, correct? This is my region of accepting the null hypothesis. So I am accepting the null hypothesis. And I say that the die is the fair die. I hope this is clear with all of you. I hope this one, this particular part, why do I have accepted the null hypothesis? And I say that the die is fair is clear with all of you. And then we will move to the next example.
Ma'am, how did we derive the significance level here?
In the example, you will get the significance level directly in the exam. So in the exam, as you can see, this particular statement is the screen. I think screen is not shared now. No, let me share it again. Here is the screen, right? So on the screen you can see that the critical value 5% df5 is 11.07. This particular statement will be given in the exam. Are you getting this? Whenever you get a numerical in the exam, you are supposed to the significance level. Of course, I do my experimentation, I will be assuming the significance level. But when we solve the numericals in the exam, we get the significance level by default. Means they say that, okay, you take the significance level as a 5%, or sometime it will be said that take the significance level as 1%. That means 0.01. Sometimes it will be taking saying that they take the significance level as a 10%. So like this, the significance level will be given in the exam. So again, I will repeat the importance of the significance level. The significance level says that how much confident I am that I will be getting the right result. मी तुम्हाला एक्झाम्पल मगाशी पण सांगितलं की एक्झाम्पल काय असतं. आय से दॅट माय पर्टिक्युलर वॅक्सिन वर्क्स फॉर दी 99.99%. करेक्ट. त्याचं मिनिंग काय आहे की माझं वॅक्सिन 0.01% फेल होऊ शकतं. सो दॅट्स माय सिग्निफिकन्स लेवल. आय होप दिस इज क्लिअर. मी सांगते की माझ्या क्लासचा रिझल्ट, माझी एकदम गॅरंटी आहे की माझ्या क्लासचा रिझल्ट 100% आहे. त्याचा मिनिंग असा होतो की ओके, माझ्या क्लासमध्ये कोणीच फेल होणार नाही, म्हणजे माझी सिग्निफिकन्स लेवल ही 0% आहे. माय अल्फा इज गोइंग टू बी 0 इन दॅट केस. So that's where the significance level plays the role. सिग्निफिकन्स लेवल हेच सांगतं की एक्सपेरिमेंट जो करतो, जो रिसर्चर असतो, त्याचा किती कॉन्फिडन्स आहे स्वतःच्या एक्सपेरिमेंटवर आणि येणाऱ्या रिझल्ट्सवर, हे तुमचं सिग्निफिकन्स लेवल सांगतं. आय होप द आन्सर इज क्लिअर विथ ऑल ऑफ यू. अँड फॉर द एक्झाम पर्पज द सिग्निफिकन्स लेवल विल बी गिवन टू यू डायरेक्टली. इज दिस ओके? क्लिअर झालेलं आहे तुम्हाला? प्रथमेश, काही अजून?
येस मॅम, क्लिअर.
ओके ओके, 2 मिनिटं. एक 2 मिनिट मला वेळ द्या का मी 1-2 मिनिटात घेते पुन्हा लेक्चर. 2 मिनिटाचाच वेळ द्या.
हे आहे का?
आपण पाठवून द्या. थांब 1 मिनिट. Okay, now we'll start with the two variable. That also please pay attention very carefully over here. Just a second. Are you able to hear the noise also from my house? Just give me the clear opinion. Uh, because I have done the noise cancellation in the Google Meet itself. So please give me yes or no. Are you able to hear the mixer's noise? Okay, good. So there is no noise, correct? So I will start the recording also and we'll go ahead. So now we will be looking at the example of the test, chi-square test with the test of proportions. So that's my the first is a survey of 200 people, 120 like a product, 80 do not like. So test whether the proportion is 50%, correct? So what does how to do this? So this is like again initially I have to set the hypothesis. I say so again. So please I will explain this example question again, and then we'll go over there. So this is the test for proportions, where the survey of 200 people has been taken, and 120 like the product A and 80 do not like this product. So what I have to do over here is a test whether the proportion is of 50% or not. Correct. So what does it mean? Whether I have the 50% people who like the thing or they do not like. Correct. So what I will be doing in this case is the test for proportion. That's my chi-square test. So first step is, the steps are same. So first step is formulating the hypothesis. So in the hypothesis affirmation, I say that the proportion is 50%. That's my 0.5. That's my null hypothesis, and my alternate hypothesis, it's not a 0.5%. Correct. So my expected value. आता लोक किती होते? So we have the 200 people. Correct. आणि माझं काय क्लेम आहे की 50% लोकांना they like the product. Correct. So according to my claim, I will be calculating. So in the calculation, what is my expected value? So my expected value is 200 into 0.5. That is going to be 100. Correct. say they like the products and do not like the product. So this is the another example, correct? So 100 like the product, 100 do not like the product. Now I will be formulating the table. So in the category table, I have the observed value, expected value, and likes and not like. So in the observed value, that is what is given in my example. So in my example, what I found is 120 people like the product, correct? And 80 people do not like the product. So that I have calculated in the observed value. In the expected value, what I said, 100 people are supposed to like the paper. As my expectation, my expectation is the equal proportion, that is 50%. So 100 people are supposed to like the product and 100 people are not supposed to like the product. There is a equal proportion in likes and dislikes. So then I will be calculating the remaining values. So the formula for chi-square test, as you all know, the formula for chi-square test is summation of observed minus expected the whole square divided by expected. So I'm calculated the chi-square value, and then I will be taking the decision. So first, taking the decision, I have to calculate the degree of freedom. So degree of freedom, I have two variables. So 2 minus 1, which is going to be 1. So critical value at 0% of DF1 is 3.84. My value is greater than this critical value, correct? What is my value through the test statistics? When I have this particular value, okay, look here. When I have this value is called as the test statistics value, which I get through the through the test. I hope this is clear with all of you. What I call this called as the test statistical value. This particular chi-square value test is equal to 8. So this is called as a test. So at degree of freedom of 1, how I calculated degree of freedom of 1? It is df 2 minus 1 is equal to 1. So degree of freedom of 1, and the critical value is my 5%, that is my 0.05, which is provided in the exam, correct? So this 5% of value, what does it say is that 95% of the times, 99.95% of the time, I'm confident that my experimentation is a correct experimentation, correct? And 5% of time, I say that there are chances to fail in the experimentation. That's my degree of freedom value, correct? Sorry, 95% of time, I say that my value is going to be correct value, and 5% times I'm going to say that I may fail in the experimentation. So that shows the confidence. आता तुम्हाला टेबल मध्ये you have to look after this particular value. So I have got it as a 3.84, correct? Now this table, if it is not provided in the exam, the value will be directly provided in the exam, correct? Now we will again go back to the graph which we have seen. This particular, I hope you all are able to see the graph, correct? Graph we are able to see. I will clear the value over here. Now what I have got, see, this is my significance level, correct? My answer, my test statistics is, see, this at this significance level alpha, I have the value as, what was the value? Let me go back and say it is a 3.84. So at this significance level, my value is 3.84. So this value is 3.8 and 4. Clear? This value 84. Now what I have received through the test statistics, I have received the value as 8 through the test statistics. Now where it is going to lie? It is going to lie in this region, because this in the normal distribution curve, this is my 0, correct? The value माझ्या टेस्ट क्रिटिकल व्हॅल्यूच्या रिजन पेक्षा मोठी आलेली आहे व्हॅल्यू, ह्या व्हॅल्यू पेक्षा व्हॅल्यू मोठी आलेली आहे सिग्निफिकन्स लेवल पेक्षा, म्हणून ती राईट साइडला लाई करणार आहे, समवेअर ओव्हर हियर, correct? So what does it mean? My value lies in the critical region, correct? Whatever value which will be going to lie over here, I will be accepting in that case the null hypothesis. If the value lies in this particular region, correct? If the value lies in this particular region, I am supposed to reject the null hypothesis, correct? I'm supposed to reject the null hypothesis. I hope this is clear with all of you. I'm supposed to reject the null hypothesis in this case, correct? So going back, you can see over here, they have said that reject the H0. So proportion is not 50%. I hope this is clear with all of you. Reject the H0 and so the proportion is not 50%. So this is also one of the example of chi-square test. Moving ahead, we'll see the another example, the test for variance also is there, correct? So this formula is also there. And then we have the another example, which we have seen in the class also. That was the 1500 people were surveyed and the gender of each person is noted, that is male, female, and then the preferred reading of those people are also noted, whether they like the fiction or non-fiction. And out of it, what it says is 250 people like to read, 250 male like to read the 250 male like to read the fiction, 200 female like to read the fiction, 50 male like to read non-fiction, and 1000 females like to read the non-fiction, correct? So this was what we have seen in the class also. And I want you all to solve this example again. So we will go and check the solving steps for this example. And then we have, I hope you all know how to calculate the expected value over here. The expected value is calculated in this manner. So I wanted to calculate the E11, that is the male and the fiction, correct? Male and the fiction. So count of total male, count of total fiction divided by number of candidates. That is, there are 1500 people. So what is the count of total male? We have 300 total male. What is the count of total fiction? We have 450 total fiction count, and that is divided by 1500. That the value is in 90, correct? I hope this is clear with all of you, how this value has come. And then we can calculate the chi-square formula. And then again, the degree of freedom is to be seen. So over here, the degree of freedom is 2 minus 1, 2 minus 1, because there are two different categories, the male, female, and the fiction, non-fiction, correct? So 2 minus 1, 2 minus 1, which is going to be 1. So at 1 degree of freedom, over here, I am taking the significance level as 0.001, correct? So I have a confidence that only 0.001% of time my experiment is going to be having the failure. Otherwise, all remaining times I am going to be very successful. Correct. That's what my significance level says. So the value through the chi-square table test I got as 10.828. And over here through the test statistics, I got the value of 507.93. Correct. So my value which I received through the test statistics is much higher than what the value of significance level. So what we can say that we reject the hypothesis that gender and preferred reading are independent. And we conclude that these two variables are strongly related for a given group of people. So that's why that is what my chi-square test, the another example of chi-square test. I hope this is clear about the chi-square test. Is there any question in the chi-square test?